Yeah, hi guys, today we are going to learn on how to calculate the shaded area of a circle. Alright, so we start off with the formula. I believe you guys have learned the formula, but I will just do a short recalling session. Okay, so for the area of sector, it can be either major or minor sector. The formula will be half multiplied by r square with theta. And this theta is very special that we must ensure that it's always in radian. So what if our angle is in degree? How do we convert it to radian? There's a formula here whereby if the angle is in degree, so what do? You take degree divided by 180 multiplied by pi, you'll get the conversion to radian. Or if the final answer requires you to give the answer in degree, then what do? You take this pi divided by pi times 180. That means if let's say it's in radian, so you take the radian divided by pi times 180 to get in degree. So these two formulas is the fundamental of the circular measure and also for this area of shaded region. And then I will introduce something which is quite will helpful for you in your further studies in this chapter. Okay, let me just do this correction. This should be our B here. Okay, so yeah. So but what this formulas talk about is that if you want to find the area of triangle, it will be half AB sine C. Alright, so this is something quite interesting because if you notice this angle is located in between A and B. That means in order for you to use this formula, you must ensure the angle that you input in the C, it has to be in between a two length. It can't be somewhere else, right? It must be in between a two length, right? And why do we introduce this formula? Okay, the reason is because we might see some triangle enclosed in between a circle or maybe a chord or any triangle. Okay, and the triangle might not be necessarily a right angle triangle. So what do we do if it's not right angle triangle? We can use this formula because this formula is a very general and powerful formula whereby you can use it for any sort of triangle. Alright, so without further ado, we'll go to the question. Alright, this is the simple diagram. I extracted this question from past year, right? So technically all this area is shaded and we are required to find this entire area, okay, this shaded region. So if you notice, alright, this triangle here, alright, let me just do this amendment. It's a right angle triangle. Alright, so the formula to calculate the area for right angle triangle is 1 over 2 height times base. So let me just brief you how we're going to tackle this question. We have a right angle triangle and a major sector. So we need to find them separately and we can add them up to get the total area. So if I want to find this right angle triangle, we can use 1 over 2 height times base. But the problem is that we have this length which is 10.1 and we have this length which is 12 because it's a radius of a sector. But we don't have this, so we only have the hypotenuse and the height, but we don't have the base. So we have to find the base. So if we have these two, we can use Pythagoras easily to obtain this base. So I utilize Pythagoras by 12 square hypotenuse minus the height, and that will give you the AC length, which is known as the base 6.5. So what I will do next is I will utilize this formula, okay, just to show that it can be done to get this area here, whereby 1 over 2, 6.5 which is here, 12 which is here, and then 1 radian is here. I know in sine we must make sure that the angle that we substitute must be in degree, but to save time what we can do is we set our calculator mode to radian and then we compute this calculation so that we don't have to do this conversion unnecessarily and waste a lot of time. So when you convert your calculator mode into radian, you'll directly obtain your answer in degree. So once you obtain in degree, so I mean the calculator will compute assuming it's in degree and do the calculation, you got the length. So once you got so we assume we already technically achieved this area of this triangle. Now we want to find for this major sector. For this major sector will be technically we have to find this angle first. Alright, so to find this angle, we know this is a straight line, so for a straight line it will be pi. So if you want to find this angle, it should be pi minus 1 rad, that will give you 2.4 radian. So now we can utilize this formula that we learned earlier to find this area. So it will be 1 over 2 r square theta, which is in radian, we replace inside, we get 154.2. So we already got this angle, this area which is this triangle and this area which is this major sector. We add them up and we get the answer, right? So overall what we can see is that we just need to utilize this formula very well and this formula and a conversion. Just with using this tree you can solve almost all the problem involving shaded region. I hope that this video helped you to understand better how to solve problem involving shaded region. Thank you.